All right, gentlemen, here we are with some notes for you on vocabulary that we'll be using in the algebraic expressions unit. So you should have a sheet on which to take notes. It's a handout, and it tells you to take notes on algebraic expression. And I'll start off with this little slideshow here. You'll see a lot of the boxes that you need to fill in are filled in as we go along. So first off, you got the top four elements on that table. Algebraic expression. What exactly is an algebraic expression? Well, we'll have a definition here. I want you to write this in. An algebraic expression is an expression composed of one or more algebraic terms. You might think, well, it's kind of just bouncing me back. I have to figure out what algebraic terms are. So algebraic expression maybe doesn't take me very far. But you see with the examples, it kind of shows what we mean here. If I want an example of an algebraic expression, that means just one or more algebraic terms. That means it could be something like this, 2x squared y minus 3x. Could be just, like you see here, it could be just one algebraic term. Like if I just have 2x squared y, that counts on its own. If I just stop there, that still counts as an algebraic expression. But this one here, I've got two terms, so we'll see later that that's got a special name. We'll call that a binomial. For now, all I want you to know is if I've got one or more algebraic terms, I've got an algebraic expression. So in order to understand what we mean by our definition for algebraic expression, we need to have a clear idea of what an algebraic term is. And an algebraic term is just a number, a letter, or a product of numbers and letters. Usually when we think algebraic, we say, okay, well, it's got to have some letters in there. It's going to be something like x, like the first example we have here. Or even 4y, where I've got a number and a letter together. That's one term. 4y is one term. But you could also have something, you see there, one of the examples there is the number 1. Number 1 can be a term, an algebraic term, right? If I have an algebraic expression that's something like 3x plus 1, then I've got two terms in there, the 3x and the 1. I could also have something negative there. You see like a negative fraction, negative 1/2, or a decimal, negative 0.3z, right? Those are all examples of terms. Now, I mentioned that a simple number like the 1 in that example there still counts as an algebraic term, but it's also got a special name. That's what a constant term is. Any term with no variables, so just a plain old number, is a constant term. So some examples, you have 8, it's just a plain old number. You could also have fractions, you could have negatives, you could have decimals. Anything like that is still a constant term. As long as there isn't a variable in there, it's a constant term. I just used that word variable, which I think you guys all know from last year. Variable, as opposed to a number, like a constant term, your variable is a letter that can vary in terms of what it replaces, right? It's standing in there for a number. Sometimes when we're dealing with equations, we know that the variable is some number that we still have to find out. In other cases, the variable isn't a single number all the time, but it can stand in for a whole bunch of numbers. We'll see that more in later units. Okay, so an example of a variable, I don't know, x works for me. Y, that's another variable. T is another variable. T, you'll end up using that a lot in science class as a variable to represent time when you're trying to solve for things like involving speed problems. All right, so those are the top 4 lines of your table, but there's another 3 to fill in. Got to figure out what an exponent is, what a coefficient is, what the degree of a term is. I think you guys all know what an exponent is, right? Exponent's that little number above and to the right. Here you see in red the 3x squared. That 2 is an exponent. It indicates the power, right? So if I see 3x squared, what that means is the 2 is telling me that's like there are 2 x's. You say, well, okay, then couldn't I just write 3xx instead of writing 3x squared? Kind of. It's not proper expression to write 3xx, but it's also because mathematicians are kind of lazy, right? Instead of, let's say I have 3x to the power of 6. It's a lot easier to write 3x to the power of 6 than to write 3x, x, 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 right? You lose track of all the x's that you're writing. Now the red 2 up there, that's your exponent. And the other number you want to watch for in an algebraic term is your coefficient. That's the number that shows up before the variable. So in that example that we just looked at for exponent, the coefficient is 3. Right? In these cases here, if I have 3x, then the number in red is my coefficient. The coefficient of 3x is 3. Coefficient of my term is minus 2y. There, then my coefficient is minus 2. The minus is part of the coefficient. Right? And if I have something like minus z, that one can be a little bit tricky. The coefficient there is actually minus 1. I didn't write the 1, but whenever you see a minus in front of a variable like that, it's really because you're saying minus 1 times z. And the last example, 0.7r. A coefficient can be any kind of number. It can be a fraction, it can be a decimal, it can be negative, it can be positive. Now, last one to fill in, probably the most complicated one, the degree of a term. The way you figure out the degree of a term is you get the sum of the exponents of the variables in an algebraic term. Okay, the sum, that means adding together of the exponents, and you all know what exponents are, of all the variables in an algebraic term. Notice it's the sum of the exponents of the variables. You may have some exponents in there that aren't on the variables. You might have, for some strange reason, you might have an exponent on the coefficient, but you wouldn't include that to figure out the degree of a term. So let's look at some examples here. Let's say I have x cubed y squared. Right? I look at all the variables that are there. I've got x as a variable, y as a variable, and I've got an exponent of 3 for the x and an exponent of 2 for the y. So to get the sum of those exponents, I got to add them together. 3 plus 2, which somebody told me a long time ago gives me 5. Looking at z to the power of 4. So what's the sum of the exponents of the variables in that term? Well, there's only one variable, it's z. So 4 is the exponent of that variable, and there's no others to add it to, so my answer is just going to be 4. Put in a couple of more examples here, because this one can be tricky. Right? If I have minus 3x, you might say, well, I don't see any exponents anywhere, so there's nothing to add. But even though we don't write an exponent up high on the x, there's actually a power of 1, right? There's an exponent of 1, like a little invisible 1 that we don't write there. So it's actually an exponent of 1, and if we look at all the variables there, x is the only variable, I have 1 for x and nothing else to add it to, and the degree of that term is going to be 1. Last of all, I see the number 8, right? It is a term, even if it's a constant term, even if there's no variable in there. It feels like, well, that doesn't feel very algebraic, but it is an algebraic term. We've got a constant term that's 8. And if we say, well, then what's the degree of that term? You look and see, okay, let me find all the variables in 8. There are no variables. So that means there can't be any exponents of variables, and it means there's no exponents of variables to add together, and its degree is just 0.